Hello and very warm welcome. In this video, we would be discussing about units of force. Force is an agent whose action can produce acceleration in the body. By Newton's law of motion, we can say that the rate of change of a momentum is directly proportional to the applied force. This is point number one. And then the change takes place in the direction of applied force, which is point number two. According to this law, mathematically we can say that force equal to mass into acceleration, m into a. Using this, we can obtain units of force. In terms of absolute units, or in terms of SI unit, force is measured in Newton, named after scientist Isaac Newton. Let's say mass equal to 1 kg and acceleration equal to 1 meter per second square. Then we can say F equal to m into a, which means it would be 1 kg into 1 meter per second square, resulting to 1 Newton. So what can be 1 Newton again? If we have to define 1 Newton, I can say that 1 Newton is that much force while acting on a mass of 1 kg, producing an acceleration of 1 meter per second square. Very simple. This is in terms of SI unit. Now, when it comes to CGS unit, how will it look like? In CGS unit, means force is measured in dyne. Short form is dyn. Here, let's say mass equal to 1 gram and acceleration equal to 1 centimeter per second square. Then, according to the force formula, m into a would result into 1 gram into 1 centimeter per second square, resulting to 1 dyne. So, how can we define 1 dyne? 1 dyne is that much force while acting on a mass of 1 gram produces in it an acceleration of 1 centimeter per second square. This is in terms of CGS unit. Next, let's see the relation between Newton and dyne. Next topic is relation between Newton and dyne. Now, 1 Newton equal to 1 kg into 1 meter per second square. 1 kg means 10 to the power 3 gram or 1000 gram into 1 meter equal to 100 centimeter. So 10 to the power 2 centimeter per second square, which would result it to be 10 to the power 5 gram centimeter square. Centimeter second square, which absolutely gives me 10 to the power 5 dyne. Therefore, I can say 1 Newton equal to 10 to the power 5 dyne. This is the relationship between Newton and dyne. Next, coming to gravitational units. In terms of gravitational units, force is measured in kgf, kilogram force. Okay, so in gravitational unit, force is measured in kilogram force, kgf, or kilogram weight. Let's say m equal to 1 kg and acceleration equal to 9.8 meter per second square. According to the formula, if I substitute it, it would be 1 kg into 9.8 meter per second square, resulting out to be 9.8 kg meter per second square, which means 9.8 Newton, giving me as 1 kgf. Now, 1 kgf is that much force while acting on a mass of 1 kg produces in it an acceleration of 9.8 meter per second square. This was my SI unit of gravitational force, or SI unit, in SI terms. Next, in terms of CGS, how will this gravitational unit look like? Let's understand that also. So here, force would be measured in GF, which is nothing, it's a gram force or gram weight, which is GWT. Again, I would say, let's say m equal to 1 gram and acceleration equal to 980 centimeter per second square. Then according to the formula, it should look like 1 gram into 980 centimeter per second square, resulting me to 980 gram centimeter per second square, which is nothing but 980 dyne. 980 dyne means 1 gram force. So 1 gram force is that much force which, while acting on a mass of 1 gram, produces in it an acceleration of 980 centimeter per second square. This is how units of force are obtained. See you in the next lecture. Thank you.